Hello, everybody. I hope everything is fine. Today, I'm going to take you to the heavens. No, not that heaven. I don't have the key. Um, I'm going to take you to the galaxies and the skies. Now, this is the Milky Way galaxy, or let's say as the Milky Way galaxy as the scientists think it would look like. You know, we are stuck in the disk of the galaxy, so there's no way to go up and have a bird's eye view. But scientists, the astrophysicists, they look at the far away galaxies, and they can see them by their magnificent telescopes. And then they can, by comparing the distances of the stars, and they can come up with this. Yeah, it's not our concern to go to the details. But anyhow, this is the galaxy, and there are between 200 billion to half a trillion stars in any typical galaxy. So it's quite huge. Now you might think that, okay, we have stars, we did different types of stars in the galaxy, which is correct. And we also have something which is quite mysterious. It's called a black hole. Now, how black holes are made is quite complex. Now we have stars, and most stars live a long life, like 10 billion years. Our sun is like that. And then we have some stars which are very big, very big. They burn their fuel, their material quite fast, much faster than normal stars. And a massive star has a very interesting lifespan. Initially, it fuses hydrogen to form helium, and then this produces energy. Then the ashes of that reaction, the helium, fuse together to form carbon and oxygen, releasing out more energy. And then the carbon and oxygen can fuse together to make heavier elements like magnesium and sodium and things like that. And then after that, the silicon and sulfur, and finally iron. When the star starts making iron, the great star is doomed. Yeah. And at the core of the star, the nuclear energy tries to push the material outwards, while gravity tries to pull them inwards. Eventually, gravity wins, and all outer layers collapse with the iron core. All of them collapse into the center of the star, and then they rebound in a very massive explosion, which is called a supernova. And what is left is usually either a neutron star or a black hole. It's a very small place with very strong gravity. The gravity is so strong that even light cannot escape. So you cannot see a black hole. Theoretically, when you have black hole, I mean, that part of the space that cannot will not allow the light to escape from, you can, again, theoretically have the other side, the opposite phenomenon, which is called a white hole. This is what a black hole may look like, and I mean, if you get so close to that to see it, it would be like that. Theoretically, it's not possible. And as I mentioned, if you have the reverse of a black hole, theoretically you can have a white hole, and this is what theoretically a white hole might look like. Now, I would argue that though black holes and white holes are in the sky and galaxies, we might also see some similar phenomenon down in our own Earth, the small blue and pale Earth. More specifically in the Middle East, again, more specifically in Iran. Now I'm going to show you the black holes and white holes which can be seen on Earth. Now, this is the black hole that I'm referring to, a black turbine. And now we have the other one, which is a white one. So we do have black holes and white holes among people. Now, remember the main characteristic of a black hole? The gravity pulls everything in, the strong gravity, strongest possible, not even imaginable. Gravity pushes everything in, even light cannot escape. Now, when you have these black and white holes on the Earth, as soon as they put them on the head, nothing human can be seen. No kindness and compassion and mercy and beauty, nothing can escape from the head who has this white hole or black hole around. And that's the reality. Now, another notion which is important in astrophysics is a portal which can take, again, theoretically, take material to other dimensions or other even universes, which is called a wormhole. Well, this might be a wormhole, although it's not necessarily this long. Again, this is the substance of lots of science fiction products. And so many people think that if you have a black hole and a white hole, and then somehow they're connected, that would be a wormhole. And I would say yes. Yeah, we have something like that. And then and theoretically, it is possible to move in time and place. And scientists so far have not been able to show it, but I think it's quite easy. When you have this, the black hole and the white hole and the wormhole, we have experienced that. At least this wormhole can take us back to 1400 years ago. We have seen that. Then finally, let me sincerely wish for a time and space when and where these black holes and white holes do not exist, and the wormhole does not want to take us or move us to heaven and paradise without our liking it. That would be a very beautiful world indeed.